Okay, so in this next part here, we're going to look at using our resolving ideas with more complicated situations. We're going to use this block of text here, first of all, to try and make a diagram. A smooth bead, so bead, I'll talk about in just a second, is threaded on a string. And then, if you haven't already, I'd encourage you to pause this video and have a go at drawing it. It's surprisingly challenging. Eventually you'll come up with something like this, hopefully. Okay, so you can piece that together and it's a good skill for you to practice. How do I know that it looks like this with this force at the bottom? Well, it said that it's held in force, it said it's directly underneath, and the force here must be about there, because if it weren't, well, the particle would want to hang directly in the middle, wouldn't it? Okay, so with a little bit of visualization, a bit of thought, you should hopefully be able to come up with this without too much trouble. So we then need to resolve it the usual way. So it's either going to be up, down, left, right. So I would encourage you to do up, down, left, right on this question because, well, it kind of fits the diagram, and that's the general advice. So I'm going to make that one there horizontal. Let's do some verticals. I'm going to say that that's that one there, isn't it? How to handle this T? I could draw it sort of up here, but I think that's a bit confusing. So what I'm going to do with this one is I'm actually going to draw this one out slightly separate, so it's less confusing. So it should look something like that one there. Let's put some forces on it. So this is T, and this diagonal is also T. They're the same T because it is a bead, is the idea. Okay, so anything else I can do? Yeah, because it's a Z angle, that's also 30. So I'm going to write this purple one across here as T cos 30. Okay, and this one here I'm going to write as T sine 30. So just check that you're happy there with how I've said that these bits together make up this diagonal line here. Okay, and then I'll tell you what, I'll just put it all in the same color so it's easy for me to think about. So I'm ready for my equations now. So my equations are going to be the green ones. Now, something interesting, if you do the green ones, it's going up and it's going up. So it looks like you're missing something because it said it was an equilibrium. So what we're missing then is we're actually missing the weight of the bead. Otherwise, you see you have two arrows up and no arrows down. It doesn't make sense. So what we're going to do is we're going to say that T plus T sine 30 should be equal to W. And for the purple ones, we can say 8 equals T cos 30. If we put those ones together. Okay. It's not a light bead, it's a smooth bead. So that's why it's still got W. And notice that you can kind of catch yourself making a mistake with that one. What are we trying to do here? We're trying to find the tension and the weight of the bead. Okay. So if you use the one underneath, 8 over cos 30, it's going to be equal to T. And have I got my numbers somewhere? Worked out probably 4. Yep, I've got T is equal to 9.24. And if you use the top equation, you should then be able to get W is equal to 13.9. No, it's not a degrees, is it? It's just a weight, it's a force. Better answer would be put newtons on the end because they're forces as well. So yeah, that's how we might do that one there, for example. We're going to have a go at another one now where we've got a big block of text. We're going to try and work out exactly what it looks like. So we've got a mass of 3 kilograms rests on the surface of a smooth plane inclined at 45 degrees. So this is going to be one of these ones. Okay, 30, a block. So I'm going to do something like this. Zoom in a little bit. Mass 3 kilograms. So 3G. Anything else? Smooth. Attached to a cable, pulls it over the top of the plane. Right. Seems to be some kind of tension because you've got like a pulley on the top. And then there's a mass on this one of 1 kilogram. Okay. The masses are modelled as particles, the cables are light in sense. There's a force of P acting horizontally. Well, that must be like this then, no? So there's a force called P. Anything else? Right, I want to zoom in a little bit now because I think I'm a bit ready to work with this. So hopefully you've got some initial ideas of what to do. I'm going to call that T, because that's tension, because that's a string. I've got P here. Something that's definitely missing is R. Okay, because you've got to have a normal reaction. So let me show you a neat version of this one here, and we'll do some work with it. So where's my neat version? Where did I put that? My neat version is over here. Okay, so this is how you might sort of draw it, for example. So I've got 3G down. Let's finish these off. Let's sort this diagram out. So that's 45. Remember we said that this angle always matches this angle here. I've got 3G straight down. What would I do with it? Well, this is the adjacent side, so it's cos, and it would be 45, wouldn't it? Underneath here, this is opposite the angle, so this is 3G sine 45. So can you see again, we've broken this one up. T's the tension because it goes over some pulley and sort of attaches to something else. R is R because it's the normal reaction. P, look at what we've done with P here. So the angle is 45 degrees. You might be expected to know that that angle is 45. Why is it 45? Well, the reason why is it's a Z angle, isn't it? So this 45 at the top matches the one underneath. And then if it's opposite the angle, that's a sine 45. And this one here is a cos 45. Okay, so that's how we could make our diagram for this section here. Yeah. So now let's try and solve it, and let's do the normal steps. So the normal steps, I'm going to use my colours. So I'm going to do horizontal, well, not horizontal, this is parallel, isn't it? Parallel I'm doing in purple. Okay, T is a purple one as well. That's all the ones on this block. I'm going to leave this one alone right until the end, okay? I'm just focusing on the main block first. Let's do the other ones. So let's go green for these ones here. So I've got an R. I've got that bit there. Look at that, a green and a purple together make that weight. That's a good sign. This one here, so that one there, they go together, and again that makes P. So that's everything for that one there. We'll write some equations for, this is what I call the perpendicular one, and then we're going to make some equations for what I call the parallel one here. So let's do the perpendicular. So the two forces acting into the slope are P sine 45 and 3G, let's do that again. Come on now. So that's 3G cos 45. It's a plus because they're both going the same way together. And then that's going to be equal to R. Yeah? These ones here, I've got two going up the slope. So that's P cos 45 is going up the slope. T is also going up the slope. So that must be equal to the one going down the slope, which is 3G sine 45. So the same sort of thing as before. Notice it's all about getting the right force diagram really at the start. Let's do this other particle at the side. So that can have its own colour. Let's do this one here. This is just T equals G if it's in equilibrium. Let's just read and check that it's in equilibrium. So the masses are modelled as particle. Where did it say equilibrium? Okay, the system is in equilibrium, it says. Okay, the system is in equilibrium. So that's how I get that. This one, I'm doing the same thing as well. So you get your three equations here. Calculate the magnitude of P. So what's the easiest way to do that? It's going to be solving a few equations, isn't it? So if I know that T is equal to G, I can use that anywhere in the diagram where T appears. So here, for example, I could rewrite this one now. I could say P cos 45 plus G equals 3G sine 45. So can you see from there, I should be able to get P. If you just take away G from both sides, divide by cos 45, and the value that you're looking for on that one is 16. It rounds to 16 to two significant figures. Okay, so 16 for that one. The normal reaction, okay? So the normal reaction is R. So how would you get R? Well, you'd sub in that p-value that we just worked out, okay? And that's actually all you would do. So R, you should end up finding, is 32 to two significant figures, okay? And let's answer the final bit of the question. So the final bit of the question is what? The final bit of the question is state how you've used the assumption that the pulley is smooth. So smooth means that it has no friction, and if it has no friction, what's the consequence? Well, if it has no friction, it means that the tension will be the same on both sides of the pulley. Okay, so that's your first sort of complicated example, I would say there. We've got to draw the forces nice and carefully. We've got to make sure we have right angle triangles in the right way, but then the rest of it is we sort of go with the same thing as before.